Dear Chairman, thank you for your introduction. Dear ladies and gentlemen, I'm Marko Orešković. I'm coming from University of Belgrade, Faculty of Civil Engineering, and today I'm going to talk about the use of hydrated lime and cement bypass dust as alternative fillers in hot mix asphalt. Before I continue, I would like to acknowledge to my co-authors, Stefan Trifunović and Associate Professor Dr. Goran Mladenović. So, after a short introduction, I will explain materials and test methods used in this study, show obtained testing results, discuss them, and finally give summary and conclusions. So, the lack of natural and high-quality materials requires a search for an alternative solutions. One of them is definitely hydrated lime that has started to be used in asphalt mixtures since 19th century, but a more extensive use started since 70s years of 19th century. Main application of hydrated lime is actually it is used as anti-stripping additive because it changes polarity of aggregate particles, and that way improving the bond between aggregate and bitumen. Also, it improves rotting resistance, decreases bitumen aging, and overall it increases the durability of asphalt mixtures. There are several ways to add hydrated lime in asphalt mixtures. One of them is to put it as pure hydrated lime, then to mix it with filler, to put it as dry to dry or dry to wet aggregate, or by marination process. Amount of hydrated lime is typically between 0.7 and 2% in asphalt mixture. What about the cement bypass dust? That's a kind of waste material that is produced during cement production in a dry kiln. So during production of clinker in rotary kiln, huge amount of hot gases are created that contain huge amounts of sulfur and chlorine, and they are removed from system through bypass, and on that way, actually these gases are mixed with dust, on that way obtaining cement bypass dust. So cement industry is trying to spend this material, and so we decided to use it in this study with overall aim to assess the possibility of using these materials in asphalt mixtures. In this study, 4 mixtures were prepared. All of them contained stone aggregates of eruptive origin except sand that was of limestone origin. Also, all of them contained bitumen 5070 and 3 different types of filler. Control mixture contained only 5.3% of limestone and 5% of bitumen. Mixture with partial replacement of mineral filler with 2% of hydrated lime and 3.3% of limestone mineral filler, also having 5% of bitumen. Third mixture consisted of 50% of limestone natural filler, 50% of cement bypass dust, but with a slightly lower optimal binder content of 4.7%. And finally, 4 mixtures contained only cement bypass dust as filler. All of these mixtures were further subjected to testing in order to determine their volumetric properties, water sensitivity, freeze-thaw resistance, rotting resistance, and their stiffness. Considering component material, it can be seen that hydrated lime has the lowest particle density and cement bypass dust has the highest. But both of them had very high rigged and void content compared to the natural limestone mineral filler. That caused the higher air void content in all of these mixtures and also decreased amount of voids filled with bitumen. So first test was water sensitivity according to European norm, where Marshall specimens were compacted with 35 loaves per each size. Samples were divided into the 2 subsets, and indirect tensile strength of dry or unconditioned subset was determined, showing that all of mixtures have more or less similar ITS values. Wet subset was saturated with water in vacuum excicator under the pressure of 6.7 kilopascals for 10 minutes plus additional 10 minutes. On that way, saturated samples were placed in water bed at 40 degrees for 70 hours, and also their ITS were measured. It can be seen that water brought to the decreasing of ITS, but measure of water sensitivity is actually the ratio between wet and dry subset of samples. Typically, this ratio depends on the technical requirements, but it goes from 70 to 80%. So all of these mixtures, except mixture with 100% of cement bypass dust, had satisfied value of ITS ratio. Next test, more aggressive, I would say, so-called repeated Lotman test, was performed for this study. Marshall samples with 6 to 8% of air voids were compacted and divided into 4 groups, 1 dry and 3 wet. Wet subsamples were partially saturated with water in vacuum excicator to a range of between 60 and 80%, and then placed in bags and wrapped. After that, samples were placed in a fridge at minus 18 degrees for at least 15 hours, and after freezing, they were placed in a water bed at 60 degrees. After that, they were immersed in water at 25 degrees for at least 1 hour, and this procedure was repeated for 3, 6, and 9 times. After these cycles, ITS values of all subsets were determined, and the measure of freeze-thaw resistance was defined as the ratio of conditioned subset and unconditioned subsets. Testing results of unconditioned samples more or less confirmed the water sensitivity testing results. So all of these mixtures had almost the same ITS. However, after only 3 freeze-thaw cycles, all mixture except mixture with hydrated lime had dropped ITS value. After 6 cycles, trend was more or less the same, but after 9 cycles, all mixtures except mixture with hydrated lime had almost the same ITS ratio. But mixture with hydrated lime had almost the same ITS ratio as after 6 cycles, showing that freeze-thaw resistance has no influence on this mixture. Next test was rotting resistance that was performed according to European standard by using small size device in air. Testing temperature was 60 degrees, and samples were subjected to 20,000 passes. Results showed that mixture with hydrated lime had slightly worse rotting resistance compared to control mixture, while both mixtures with cement bypass dust, regardless its content in mixture, had significantly better rotting resistance, but probably due to lower binder content. And finally, stiffness of this mixture was determined according to European standard as well by applying indirect tensile on cylindrical samples. And the tests were performed at 4 temperatures and 3 different frequencies. Obtained results were then fitted into master curves using Arrhenius equation. What does this mean? It means that data obtained in the testing data were fitted on both sides in order to obtain unique master curve at the reference temperatures in order to estimate behavior of these mixtures out of testing frequencies. Testing results show that in the domain of low temperatures, mixture with hydrated lime had the lowest stiffness, while mixtures with cement bypass dust had much higher stiffness. In the domain of high temperatures, here cannot be clearly seen, but mixtures with cement bypass dust had slightly higher stiffnesses, and that actually was approved before in the test with rotting resistance. And finally, here are some summary conclusions. So replacement of mineral filler with hydrated lime brings the increased air void content. It significantly improved freeze-thaw resistance and decreased rotting resistance and stiffness. This is a bit unexpected, but similar behavior have been found also in previous studies. Replacement of mineral filler with cement bypass dust, regardless its content, increased air void content and decreased optimal binder content. It decreased both water sensitivity and freeze-thaw resistance, but it improved rotting resistance. So, final conclusion can be that both fillers used in this study can be actually have a potential to be used in asphalt mixtures. As I said at the beginning, there have been many studies related to the use of hydrated lime in asphalt mixtures, but there are not so many related to the use of cement bypass dust. So, wider application of cement bypass dust requires additional tests, such as low temperature cracking, fatigue resistance, then determining of its impact on binder aging, and etc. Thank you for your attention.
Thank you, Marko. Any questions?
Excellent presentation. Does the hydrated lime which you use work on all aggregates? Does it work on granites and gabbro as well? Or is there a consideration in terms of the type of aggregate? That's one. And the second one is, have you also looked at the ASTM boil test, which is more like a torture test because it tests the mixes at 100 degrees Celsius? Thank you very much.
Thank you for the question. First, in this study, we used only aggregate of eruptive origin. So this is actually initial stage of tests, and here only, I would say, this is just part of our research, but we didn't perform tests related to boiling. In next phase, we will perform some chemical tests, and also we will see what is the influence of cement bypass dust on binder aging, because that is more or less the most important issue related to the alternative fillers.